Hello everyone, we have come to the final law of Mendel now, and this is the third law of Mendel, which is law of independent assortment. The statement for this law is the genes of different characters located on different homologous chromosomes, they are independent to their segregation and assortment. We have already seen in law of segregation that segregation means the separation, and here one new word come, which is assortment. Assortment means the combination of the things. Now let's take the case here of dihybrid cross. In the dihybrid cross, while we were doing the selfing of the F1 individual, we had this genotype with us. So if you have not watched my video on the dihybrid cross, please do so before coming to this one. This was the genotype of the heterozygous parent. Now, according to Mendel, each allele was located on a separate chromosome, right? So, this was the case as per him. Means these alleles were located on different chromosomes like this, right? You know that whenever law of segregation happens, it will separate this R with small r, this capital Y with small y, right? This is law of segregation which will separate the alleles. Now, law of independent assortment says that the alleles are independent in their segregation and their combination. By combination, we mean combination of this with this, combination of capital R with small y, combination of small r with capital Y, and combination of small r with small y. So, alleles are independent in their segregation and in their assortment. But this is not the practical case. We have so many characters in our body, to name a few: your eye color, your shape of the neck, your height, your complexion, your shape of the ear, your shape of the eyes, your shape of the lips, right? To name a few, these are few characters.
Please don't forget to like, share and subscribe my channel. Don't forget to press the bell icon for the recent updates.
So, chromosomes are only 46, but characters are many, and it's not possible that the allele for each character will be located on each chromosome. Otherwise, we would have only few characters, but that is not the case. Mendel was quite lucky because he chose the pea plant and in it this thing was applicable. But when he died, when scientists they reworked upon the Mendel, they found that it is not universally applicable. That is why we say that law of independent assortment, it is not at all universally applicable. So we have seen that there were three laws given by Mendel in a sequence: law of dominance, law of segregation, law of independent assortment. Out of these three, only there is one law, which is law of segregation, which is applicable on any genetic cross. So while law of independent assortment will come, you have to explain the complete dihybrid cross, but you will show this pictorial representation for both the parents, because we have taken both the parents as capital R small r, capital Y small y. So this type of representation will come here, and the examiner will understand that you have understood the law of independent assortment. So overall summary of independent assortment is that each allele is located on a separate chromosome. However, if we are talking about all the organisms on earth, this law is not applicable because alleles of a character, they are very high on one chromosome. Means one chromosome will contain a number of alleles of different characters and all will come together in a gamete, right? This will give rise to one more phenomenon which is known as linkage. And linkage is a part of this chapter only. We will study in detail in a separate video. So this is again important. Please stay tuned for rest of the videos. Thank you everyone.